Welcome to today's Energy Central Power session entitled Outage Management Helps Gainesville Regional Utilities Prepare for Hurricane Season. Now I'd like to turn the floor over to our moderator, Chris Warren, to kick things off. Chris, welcome to the event. You have the floor.
Thank you, PJ. And welcome everybody to the webinar. As PJ said, the title is Outage Management Helps Gainesville Regional Utilities Prepare for Hurricane Season. My name is Chris Warren, and I'm going to be the host and moderator for today's event. Now, the focus of our discussion today is how Florida's Gainesville Regional Utilities, or GRU, worked with AspenTech and UDC to upgrade its outage management system to be better prepared to serve its customers when hurricane season began. Now, if you came to the webinar today because you work at a utility that experiences hurricane season every year, you really are going to want to stick around and learn about GRU's experience and thinking. But I think it's also important to understand that GRU's experience improving its outage management system is relevant to utilities that haven't had a hurricane come within hundreds or even thousands of miles of their service territory. A focus on bolstering outage management systems and capabilities has arguably never been as important as it is today. Hurricanes, obviously, are just one example of extreme weather. And across the nation, utilities must navigate increasingly frequent and severe extreme weather. From the wildfires that have so devastated Los Angeles recently, to tornadoes, blizzards, and extreme cold and severe flooding. And I can put some data behind that. The National Oceanic and Atmospheric Administration, or NOAA, highlights the trend in extreme weather and underscores the importance of utilities focusing on having the most robust outage management system possible. In 2024, so last year, NOAA reported that there were 27 weather and climate disasters that caused $1 billion or more in damages. These included Hurricanes Helene, Debbie, and Milton, but also there were hailstorms in Texas and flooding in the Midwest. Now, NOAA has been monitoring billion-dollar weather and climate events since 1980. And over the 44 years that they've been monitoring, there's been an average of 9 events per year. But fast forward to 2020 and 2024, that average jumped to 23 events per year. Utilities understand the connection between extreme weather and outages, obviously. They deal with it every day. And in fact, an analysis of power outage data between 2000 and 2023 found that 80% of all outages impacting 50,000 or more customers were due to weather-related events. Now, obviously, outage management has more immediate importance before, during, and after a big storm. But the truth is that it always matters. Having visibility across a utility's network and being able to pinpoint and respond to the sources of outages is key to fast restoration times, strong SAIDI and SAIFI scores, and customer satisfaction. So we're fortunate to have a group of speakers here today who can walk us through their experience updating GRU's outage management system in advance of this year's hurricane season. We're going to learn about why Gainesville chose to update its outage management system, the type of collaboration that was necessary between the utility, AspenTech, and UDC to complete the update quickly, and the benefits GRU has received now that the update is complete. So, a lot of ground to cover, and we're going to jump right into it. So first off, I want to introduce the speakers that are going to lend their insights and experience today. First is Tony Holstein, Utility Project Leader for GRU. With 22 years at GRU, Tony brings extensive experience in utility operations, emergency management, and leadership. As Distribution Operations Manager at Systems Control, Tony served in roles such as Emergency Management Coordinator, Planning Section Chief, and Cybersecurity Incident Response Lead. Tony's expertise includes storm restoration and leading cross-departmental teams to enhance operational efficiency, safety, and customer satisfaction. Next up, we have Richard Gunton, Technical Systems Analyst at GRU. Richard has been with GRU for 20 years, serving as a Technical Systems Analyst in the Energy Delivery Operational Technology Division at the Systems Control Center. Richard plays a vital role in maintaining and supporting the outage management system, ensuring its reliability and efficiency. With advanced expertise in analyzing, designing, implementing, and maintaining departmental automated systems, Richard is a key contributor to GRU's operational technology landscape. Next, we're joined by Sally Jackaman, Vice President and General Manager for Power and Utilities at Aspen Technology, Inc. She's an industry professional with extensive experience in digital solutions for electric and gas utilities. Sally oversees the overall business strategy, including customer engagement, organic and inorganic portfolio expansion, as well as global growth opportunities for AspenTech's digital grid management product suite, which includes the AspenTech OSI Monarch SCADA, distribution management, transmission management, generation management, distributed energy resources management system, and network model management applications. She establishes and executes corporate strategies for the company's power and utility business segment to ensure continued innovation and market leadership. Sally earned a BSc in Industrial and Operations Engineering from the University of Michigan and an MBA from the Tepper School of Business at Carnegie Mellon University. Next up is Derek Paquette, Senior Director, Partner Programs for AspenTech. Derek has over 28 years of consulting and system delivery experience in the utility industry. In the last 3 years with AspenTech, Derek is focused on building a delivery service provider ecosystem for the digital grid management software suite. And finally, we're joined by Ron Yoshimura, Principal Consultant at UDC. Ron has over 35 years of experience developing and implementing enterprise software solutions for electric, gas, and water utilities. His experience includes consulting, product development, project implementations, application training, and global market development. His background in ADMS consulting includes AspenTech OSI project implementations and supporting OSI mobile product development. Ron also developed network models to support OSI ADMS applications. As principal consultant for UDC, his main objective is ensuring UDC clients are provided with pragmatic business solutions to their unique and complex challenges. All right, so we have a full roster of speakers today, and really looking forward to jumping into this topic. Tony, you're going to kick us off here. And I want you to give just the audience, they might not be familiar with Gainesville Regional Utilities. Tell us about the utility and maybe a bit about its history.
Yeah, of course. Good morning, everyone. I know we're going to be talking about the outage management system and some of the sophisticated ways it allows us to serve our customers today. But let me give you, the audience, a bit of history about who we are and the services we provide to the people living in and around Gainesville. So the utilities story is a bit unusual. Over 100 years ago, back in 1911, the city of Gainesville had a little over 6,000 residents. At the time, the local economy was dominated by agriculture, lumber, and phosphate. The University of Florida was just getting started back then. At the time, the city's electric was provided by a private company called Gainesville Gas and Electric Company. City residents were often unhappy with the service. This was especially true for the city streetlights, which often didn't work. Eventually, the city council in Gainesville got fed up with the poor service and demanded a $10 reduction in one of the city's monthly utility bills. The Gainesville Gas and Electric Company would only accept a $2.70 reduction. Tensions about the billing dispute escalated quickly. Then in early 1912, Gainesville Gas and Electric decided to cut off the power to the city. That was the breaking point for the Gainesville residents. In response to the power cutoff, citizens demanded the creation of a utility, city-run utility. They got their wish. Within a year, construction began on a power plant located downtown. Fast forward 100 years later, Gainesville Regional Utilities is the 5th largest municipal utility in the state of Florida. Today, we provide electric, natural gas, water, wastewater, and telecom services to over 110,000 customers, retail and wholesale, in the Gainesville area. A few other points that will interest the audience. We're a vertically integrated utility, and our peak load is about 400 megawatts.
Great. Thanks, Tony. I still am amazed at that history, and they would only accept a $2.70 reduction. I mean, just kind of amazing. Anyway, so that's the context. That's a great bit of history. And Richard, we're going to kind of fast forward here to the future and where we are today. So I talked about the project timeline in my introduction and the desire to update the outage management system before hurricane season began. So a bit of a ticking clock. Richard, I'm hoping you can give the audience a fuller picture of what was really driving the project. And if you could start by explaining the systems you had in place at the beginning of the project, and then just walk us through where GRU wanted to go and why. So just give us a flavor of the project and the drivers.
Absolutely. And you're correct in the hurricane season set the timeline for when we had to have the project completed. But the project was also in response to the need to migrate our existing Esri GIS to the new ArcGIS utility network. Esri was waning support on the old geometric network and was no longer providing support for it. So we wanted to take advantage of the many benefits of the utility network, or that the utility network offered. Ultimately, this was a conversion project from the utility network to a utility network. I will go into more detail about how the enhanced GIS data better represents the actual conditions on the grid and how granular data improves outage management in a bit. But before I get into how enhanced GIS data significantly improves our outage management capabilities, let me take a step back and provide some context about our distribution operations and the AspenTech ecosystem of the products that help us do our work. Distribution operations at GRU have 2 primary responsibilities. One is to manage and maintain the infrastructure that delivers electricity from the transmission system to the businesses, homes, and industries we serve. The transmission system, the second is to monitor real-time grid conditions, including voltage levels, load, and power flows. When problems arise, we are responsible for controlling circuit breakers and switches to reroute power. As is true with any utility, there are challenges to distribution operations. Load balancing is one. It's our job to distribute electricity evenly across our network to avoid overloading the system and risking outages and blackouts. We also oversee regular maintenance and upgrades to the distribution system to improve efficiency and reliability, to integrate new technologies such as smart meters and distributed energy resources like solar and batteries. And of course, distribution operations oversee outage management. When storms, equipment damage, vegetation, or animals lead to an outage, we coordinate repairs, dispatch crews, and work to restore service as quickly and safely as possible. So let's talk about the tools we use to do this work for our customers. Since 2015, we have leveraged AspenTech's digital grid management product suite across real-time operations in transmission and distribution to serve as a single system for operations. More specifically, we use AspenTech OSI Monarch SCADA, AspenTech OSI Outage Management System, and AspenTech OSI EMAP Distribution Network Model to manage outages and for post-event reporting like SAIDI and SAFE.
Great. Thanks, Richard. Now that gives us a nice kind of overall picture of the responsibilities that distribution operations has and the tools that GRU has to fulfill them. And I'm sure that will be sound familiar to a lot of our audience. And you also gave a quick preview of what this project with UDC and AspenTech entailed, and I know you were very involved with it. Can you help, can you give your experience and dig in and provide some more details about what the project involved and what you really wanted to achieve once it was completed? Nobody does these projects just for fun. You wanted to get somewhere at the end. So walk us through all of that and what you hope to accomplish.
Of course, it probably helps to just remind the audience about the aim of the project. We wanted to fully leverage enhanced and more granular GIS data to manage and respond to outages. Ultimately, this was all about using better data to better serve our customers. What did we have to do to take full advantage to improve our GIS data? Well, I mentioned earlier that we migrated to the new ArcGIS utility network format. The migration was not enough by itself to allow us the more granular data that we were seeking for our outage management and reporting purposes. To take full advantage of it, the enhanced data and new SCADA data model had to be reintegrated into our AspenTech OSI Monarch SCADA platform and network model. I know we will be hearing from Ron at the UDC shortly, but that is the job that he spearheaded and made happen in the short time frame we were working with them. Working with UDC, we also determined that our AspenTech OSI OMS software needed to be upgraded to be able to use the upgraded GIS for all of the OMS related applications. These included everything from comprehensive work management to outage analysis to storm functions and regulatory reporting. The project involved extracting and importing the new Esri utility network substation features into GRU's current model to make them a part of AspenTech OSI ADMS network. I mentioned granular data before, but let me be more specific. The new Esri utility network substation features include transformers, breakers, busbars, transfer buses, and transfer breakers. In other words, the addition of these features changed the starting point of the ADMS network model from the feeder breaker to the transformer in the substation that include the substation networks and the circuits in the trace. UDC also used the new data to configure the electrical hierarchy data for the new substations, areas, and regions. This improves the data that OSI AspenTech OSI ADMS systems uses in its automation. The ultimate outcome was that our operators had greater visibility of the network, which is key to improving outage management.
Great. Well, now in the intro, again, I'll kind of loop back to where we started. It's all about outage management. And I want you to, Richard, just, we'll stick with you here a little bit more. I want you to talk about what this all means for GRU's outage management capabilities to have that granular GIS data. Walk the audience through the benefits of that data and access to it at a big picture level. And then, on the other side, what does it meant for the operators who are using it?
Sure. Well, let's start by going back to the basics. The whole point of OMS is so that we can use data to improve our reliability. It's obviously about restoring service quickly when there's an outage, but it's also about using data to identify trends that help you prevent outages before they happen. This project moved us from a geometric network to a utility network. As I mentioned a moment ago, the geometric network stopped at the feeder. Also, things aren't configured correctly, those misconfigured items can still go on the map. That doesn't happen with utility network. The conversion gave us the in-depth visibility at a substation level with the better data going into our map service. What does this mean for outage management? Because the geometric network stopped at the feeder, if the SCADA said that a feeder was open, that was it. That was gospel. That feeder was open. We would have to assume that all the customers and all the feeders in the substation were out, which wasn't true. Now that we have the substation data, we're better able to calculate the customer outage count based on the things that are switchable inside of the substation. Before, if we had multiple feeders out, as I said, that were still being fed through the transformer buses in the substation, we couldn't remove those customers from the outage count because we didn't have that substation data to switch around. Now that we have the substation data, when those feeders are fed through the substation to the transfer bus, we can take those customers off the outage count and give a truer count to the customer. With the geometric network, we had no way of networking to that feeder to say that it was restored. It would see in SCADA that it was still open, so it thought that there was still an outage, but we didn't have the substation data to tell us that it was being backfed from within the substation. Here is what the substation level data means for our customers. Better visibility improves reliability of the distribution network because we can minimize outages and reduce our response time when the outages happen. It allows our operators to work more efficiently and manage the flow of electricity to avoid further losses. More accurate data improves safety because we can quickly identify faults, isolate problem areas, and dispatch crews. When you have fewer outages and you can respond quickly to the outages that do occur, you have more satisfied customers. Let me talk about what the substation level data means for our distribution system operators. Now that we have substation data in, we're able to model everything in our EMAP and have it on hand for our operators as an active live model. Before, the operators had to go to our one-line drawings and see if there was switching orders or distribution automation and stuff like that. Now that the manual process relying on the one-line drawings is gone, this has a direct impact on the restoration process. Instead of getting up to look at the one-line drawings to facilitate the restoration process, our operators can look to the EMAP and see where any abnormalities are. Then they can work with the line crews to say that a particular line is backfed from another source, and that creates a safety issue. But if we're able to work with crews and get them working on site, on time, safely and efficiently, we're going to have a lot better reliability numbers and happier customers in the end. I should point out that change is always hard. Even when it is an obvious improvement, there's definitely a learning curve to a new system. But now that our operators have learned and worked with the new maps, they wouldn't give it up for anything. Operators now have a single system for operations. We have the map, the OMS, and EMS are all together in one system. So the operators can view it in one system instead of having to go to another computer or monitor even hard copy maps to see the outcome of their queries. And they're also able to model in that one system, and because we have substations in there now, like I said, we don't have to go off on our paper hard copy maps that's just switching orders and other things that are abnormal that are live in the system. Plus, it goes all the way back to the breaker at the substation, and the operators are able to see that and switch around that. It makes switching a lot easier. All of which means that there are less clicks and you can move faster when you are managing outages. And you also get a much closer representation of what is going on live in the field in our distribution model system. We still maintain our one lines. If something goes down, computer system or whatever, we always have our hard paper copies. Day to day though, our operators have the answers they need at hand in front of them on the computer monitor. And as we go towards ADMS, it's going to make things a lot easier in the conversion. Everyone will still have to maintain the mindset of an operator and know how to switch and how everything works in their system, but having the ADMS backing it is going to improve the reliability numbers a little bit faster.
Great, thanks, Richard. You covered a lot of ground there, and I'm sure the audience is going to have some questions about some of what you've covered. And just as a reminder to all you watching, please feel free to submit your questions, and we'll get to them once we get to the Q&A portion of the webinar. So now we're gonna switch up a little bit and pull back the curtain on really how the project happened in such a short period of time. And there's a lot of pieces. There's a few pieces to that story, GRU worked closely with UDC, and UDC was supported by AspenTech, which is the provider of GRU's digital grid management software. But I want to start this part of our discussion with Sally Jackman, who's Vice President and General Manager for Power and Utilities at AspenTech. And Sally, I think, I started off in my conversation with Richard talking about the ecosystem of products they had available and tools. And I'm hoping that you can walk us through a bit more about AspenTech and the suite of projects, the digital grid management products that you oversee, just to give the audience a better sense of who AspenTech is and the sort of capabilities that we're talking about here and Richard went through.
Absolutely. Thank you, Chris. And I think it's important to highlight, you're right, it's certainly an ecosystem, which we're proud to highlight today with our partnership with UDC and Gainesville Regional Utility. For those of you who may not know who AspenTech is, AspenTech is a leader in industrial software for asset-intensive industries. Our digital grid management business of AspenTech, actually, many of you might know us as OSI. We were acquired by AspenTech a couple of years ago, and now we're fully integrated and known as AspenTech Digital Grid Management. What's great about that is that AspenTech really does care about like I said, the asset-intensive industries. And we think about the electric grid, power generation, gas distribution, gas transmission. All of those we think of those as giant assets, giant electrical grid assets. And this is, the core competency of AspenTech. And you can see here some of the stats of their global business, global customers across many industries, not just power and utilities, but EPCs, process industries, oil and gas, mining and minerals. So a lot of breadth and depth in the overall AspenTech portfolio. When we dive into digital grid management, what was acquired from OSI, we have a really platform-based approach. So we're 100% focused on real-time operational software to support real-time operations of electric and utilities, gas utilities around the world. It's built off of our Monarch platform approach. So we've built the system 100%, developed the system by ourselves, and it's a very modular, flexible system. So as you heard Tony and Richard talk about here, they were a vertically integrated utility. So they're using transmission, some components from our EMS, distribution, some components from our ADMS suite, our SCADA, and they're using it all together as a single system, enterprise-wide system, so their operators have one user interface, one single source for all of their operations, which really is a efficiency, not only for operators in day-to-day, but also for the maintenance and support of the system and the ease of integration, natively integrated all together. So, Gainesville is not alone. We have a number of utility customers globally, both North America and globally, that leverage our systems here, many different pieces and components of the system. So you can see here from generation through transmission, distribution, and gas pipeline, a sampling of our customers that have standardized on our evergreen product approach and a system or multiple systems to support their real-time operations. Lastly, I just wanted to touch on a few points here on, some of the key points that drive value for utilities like Gainesville. That single enterprise OT platform that allows for that common user experience and enterprise adoption across the utility. We also are a company that focus very heavily on cybersecurity and ensuring our systems are secure and from a product perspective, but also partnering with our customers to ensure that their architecture, their firewalls, and so forth are all supported. You mentioned an ecosystem, and we're talking about an interface to the Esri utility network model on this call. And interfaces are important. These systems can interface to 10, 20, 30 plus different software systems at a utility. So being able to provide an open platform and integration and support common communication standards is very important to us. We're also talking about an upgrade. So we support what's called an evergreen product approach, and we really encourage our customers to upgrade every couple of years. This not only gives them the latest and greatest features, so cybersecurity enhancements, but also enables new technologies like the Esri utility network model to be incorporated into daily operations. We want to make this an easy system for our users to use and maintain long-term, cost-effective solution. And it's also important for us to partner with both of our customers and our partners like UDC to ensure that we're enhancing our products with new features and functionality that will help them really enhance their services to their end consumers. So hopefully with that, Chris, is a brief update on just who we are and what we do here at AspenTech. Next, I'm going to turn it over to Derek here, and he'll talk a little bit about our partners and that ecosystem that is very important for this industry as we serve mission critical infrastructure.
That's right. Yeah, Derek. Thank you, Sally. That was great. And Derek is going to walk us through AspenTech's partner program, and we're going to learn about how that is so key to, again, kind of talking about the timeline of this project in Gainesville. It was rapid, and Derek is going to talk about how the partnership model helped with that, and just more generally about the goals and how the partnership model works. Derek, take it away.
Thank you, Chris. So what we refer to as our DSPs, our Delivery Service Partner Program, what it does is create an ecosystem of partners that provide the engineering services that our customers need and support, or as a part of their larger OT ecosystems. And so historically, AspenTech OSI had done all delivery in relation to the software. But what this DSP program provides to our customers is the ability to tackle these new projects and do them on their timelines when the schedules and the budgets are approved. So we've been doing this for about 3 years, pulling in together companies like UDC, evaluating them for obviously the resources and the type of work that they've done in the past, and work through enabling them and to ultimately do the integrations that were needed as part of this project and ultimately serve customers like GRU. From a perspective of why do we choose a UDC and the process that we go through, so it is a standard vendor vetting process, but it's understanding what type of resources to have, what type of experiences they bring, and do they provide additional services, i.e. what they can do on the Esri side that's so critical for our customers to enable our own software. So it's looking at what they bring to the table, what they have as far as resources, that we have brought those type of partners into our program to ultimately serve our customers, provide them options for delivering the services they need related to OMS, EMS, whatever it may be within our product suites. So this is a choice for our customers. So ultimately, GRU did select UDC, but as a part of the program, it's about bringing qualified vendors to our customers, explaining the program, talking about enablement, talking about how, you know, ultimately we come with a certain set of partners for them to then vet and actually make a system selection. So in this particular project, we spoke with GRU, we talk about the program, we give them the outline, and then ultimately, based on their interest in the program, we then transition into discussing with our partners the upcoming project, give them the details, so that ultimately then GRU can receive proposals that outline how they would staff, the experience they bring, and then make a decision that, you know, makes sense for their business. And based on the kind of the whole timeline, it's ultimately a customer being empowered to select and have service options that allow them to ultimately get a project done when they need it. And one of the things that, you know, we do with the program is it's not just throwing a project over to a UDC and a GRU, right? There's still going to be support that is needed from AspenTech to ultimately enable this project to happen. So we do have a, you know, the value assurance team essentially is technical and project governance that ensures, one, that UDC has everything they need as one of our DSP vendors to ultimately deliver the project. So making sure they have access to tools, compiles, everything that our own project teams have available to them, we make sure that they have it. In an instance like this, with the team that Ron from UDC was able to pull together, they had previous knowledge, they had the experience, but there is that portion that us as the software vendor, there is certain things we are going to know. Obviously, with all the different customers we have, there's a lot of different, no customer is the same. There's a lot of different things you need to know, and we're more than happy to provide that information to enable UDC to successfully deliver this project. So we provide those materials to our partners, so ultimately they are successful. Ultimately, our customers are successful in the delivery of the system.
Okay, that's great, Derek. You're all done, right?
All good. Thank you.
I don't want to be cutting you off with anything. All right, good. That was terrific. It sets the stage. I think it's really important context for Derek to talk about the partner system before we bring Ron in. And Ron is one of these partners, and he was the partner that was, you know, the leader in this GRU project. So we're going to bring Ron in now and have him talk a bit about UDC first. So Ron, I want you to start by telling the audience about UDC and the types of projects you do, especially with AspenTech, and then shift over and pivot and talk about, you know, how the project with GRU proceeded.
Sure, Chris, thanks. UDC was established in 2005. We have over 700 employees in 6 offices, 3 in the US and 3 in India. We have an ADMS team that's got great expertise in ADMS model development. We are certified for the model development, and we have a pretty good knowledge base, I think, because we have former employees of AspenTech on our team. This is our project timeline. This was our project timeline. We were supposed to start in January of last year, but the start was delayed. So this compressed our development and implementation timeframe because we needed to be finished by August. Our scope was really to migrate the GIS extractor from Maven to Leitmotif. We also incorporated new substation features, as Richard mentioned, in the utility network into the ADMS network model. We also updated GRU's system hierarchy. If you could go to the next slide, please. Oh. think we skipped a slide, maybe? Yes, thank you. So one of the main goals of the project was to use the new utility network source data for the ADMS model build. We also wanted to incorporate some of the substation features available in the utility network. This was to support the GRU and their implementation of advanced DMS applications from AspenTech. And it was critical that we complete the project before the start of the hurricane season. Let me give some additional background on the project and some more details. We started the project with a kickoff meeting at GRU, and the main purpose of the meeting was to do a data engineering workshop. The workshop is part of a typical AspenTech project implementation plan. The purpose of the data engineering workshop was to map the new utility network GIS to the AspenTech schema that supports OMS and ADMS. Once we completed the workshop, we felt confident that the data GRU had would support the OMS and some of the ADMS applications that they wanted to implement in the future. Following the data engineering workshop, we went into model development for the ADMS. This included migrating the existing GIS extractor, Maven, to the new AspenTech Leitmotif product. Leitmotif is needed because it supports Esri's utility network. Model development was really the bulk of the project. Throughout the model development, we had lots of testing points. We were testing constantly, and GRU was involved in the testing. And through our development work, we were able to identify deficiencies in the GIS data. We pointed those out to GRU and they corrected them. Derek spoke about support for AspenTech from AspenTech. Much of that help came in the form of AspenTech products to support the model development. Like I said, we used Leitmotif as the GIS extractor, but we also used another AspenTech product called Maestro. Maestro does the model build and has a lot of error checking in it. We use the results of the Maestro model build to find deficiencies in the source data and in our configuration. For example, Maestro helped us identify connectivity issues where things weren't connected properly in the GIS. Now that the project is completed, GRU has the latest products from both Esri and AspenTech. This should improve their OMS so that it is more reliable, comprehensive, and accurate. And the last point I'd like to make is about the great relationship we have with both GRU and AspenTech. This was really key to getting the project done before hurricane season. We would meet with Richard and his team at GRU multiple times per week, and we had impromptu calls whenever they were needed.
Great. All right, Ron. Well, that brings us to the Q&A portion of the webinar. And just before we jump in, I want to encourage people, if you have a question, you'll have time to send it in, and we'll tackle it if we have time. So the first question is, I think, probably best for Richard. The question is, do you use an automated process like in ADMS to create your EMS model? Richard, if you want to take that first, and then maybe Sally, if you have anything you want to add, you can jump in.
Chris, we might have lost Richard here, but Tony, I'm not sure. Do you want to kick that off, or can you take it that question? Oh, there's Richard.
I apologize. I had to step away to take a phone call.
Yeah. There was a question for you in the Q&A, and see if you can tackle it. It is, do you use an automated process like in ADMS to create your EMS model?
We extract it from our GIS. So Our GIS team prepares an extract for us, and we use that extract to turn it into our network model that we use for our heads-up EMAP. Does that answer your question?
Yeah.
Richard, is that both transmission and distribution that follows that process?
Right now, we only have our distribution network modeled in EMAP. In our GIS, we have both transmission and distribution, but in the future, that is what we're going to do, is we're going to bring it in both the transmission, because our substations only go to the feeding transformer, so we only have distribution in our model right now.
Great. So, I mean, that's one example, you know, from the other AspenTech users. There's a lot of different ways to automate either a transmission or a distribution network model into the real-time system, into the operational system like ours. So, you know, we have a number of customers that do model their transmission grid and manage it with the same benefits and visibility that you know, reviewing and looking at the distribution network model would be.
For the Q2, you asked, as it relates to hurricanes, how specifically did GRU use the OMS to prepare for the hurricanes? What OMS has is it has multiple modes that you can set. So depending on our upcoming hurricane, how fast it comes in, if it's a named storm, we have multiple settings for our prediction engine that we set. If it's a pop-up storm, we have one setting. If it's just a regular hurricane without a name, like a tropical storm, we have another setting. And then for a named storm, we have another. And then we have reports that we prepare before the hurricane hits. So we have several different steps that we go to prepare for a hurricane. But sometimes the hurricanes, I think it was like Helene, they just came in overnight. We didn't have but maybe 48 hours to prepare. There wasn't a lot of time, so we get as much preparedness as we can do before the hurricane hits. Does that answer your question?
Yeah, that's great. That's great. Now there's a few more questions. Let's just stick.
Hey, Chris, before we move on, I wanted to ask Richard if they're using study mode or some of the simulation tools that are in our system as well, because some of our customers do find those as powerful tools to train, you know, and do scenario planning for some of the storm scenarios that Richard just mentioned.
Some of the storm scenarios, yes, but most of the time we only use the study mode for our day-to-day switching. So they'll throw the switching into a study mode a week prior to the actual switching going in to ensure the number of customers is always zeros, such and such like that. For storm mode, they don't use the study mode quite as much because most of their switching is in the one lines and in the substations, so to say. So they're not live switching on the EMAP. They use the one lines to do that live switching for security purposes. So they do use that more, or the study mode's less during a storm, but more during our routine switching operations.
Great, thank you.
Great. So some more questions coming in. So these are specific to GRU. So here's a question. What are you using for breaker and recloser sectionalizer SCAD status points into EMAP, OMS, multi-speak, other? Richard, is that you want to?
For the parts on our EMAP, those are SCADA linked items. So it is a non-SCADA item on the map, but it has a link to the actual SCADA key in the background so that when one opens, it models on the EMAP. And we have operations turned off on EMAP, so any recloser, distribution automation, or feeder has to go through the one lines first, but they can see the model rendered and the live action on the EMAP. We don't have multi-speak to our EMS or anything like that, or any other. It's just, you know, we put the point based on the GIS location, the lat long XY on the map, and that map links back to a SCADA item so that they sync up. When one item opens, it opens on the EMAP.
Right. Tally, you want to add anything to that, or?
No, I think, well, I mean, I think that that's one way to do it. There's many different ways of doing that, and in different communication protocols and sharing ways to share data with interfaces. So I think that's a great example of one way to do it.
Great, great. Hey, Ron, I have a question here for you. I mean, it's for GRU and you, but I think it's actually an interesting question because it speaks to sort of some the relationship that you and GRU had prior to this project. The question is, did GRU have a relationship with UDC before this project started? Talk about that. I think you did.
Yes, I believe they did, Chris. We did with GRU. We had done some other projects with GRU, and I personally, I'd known GRU for many, many years. So.
Right. And that helps on both sides, I imagine.
I think so, yeah, right. We had great relationships for sure.
Right. Okay, let's see. Let me go to another. Here's another question. We often hear about a single system for operations. And again, I think this is a question for GRU, and Sally, if you want to jump in. Do your operators or ADMS users still refer to GIS for certain data that may not make sense to bring into ADMS? Sally, do you want to kick that off, or?
Well, I could do a GRU answer, and the answer is easily yes. There are some things that we have on our GIS that we don't want to clutter, bog down, or confiscate our EMAP with. So yes, they do reference like land-based things, building profiles and stuff like that on the GIS, while leaving the network model clean on the EMAP side.
And
Okay.
what I might add, I mean, that's pretty common approach for most of our customers is in the ADMS, you pull over the relevant data from GIS. And there's also other sources of data that we need to pull in, things like engineering data, protection data, things that might come from more planning systems or other databases. So the GIS isn't always the single source. Many times there are multiple sources of information that feed our EMAP distribution network model.
Right. Now we're getting lots of good questions. So I'll try to get to as many of them as I can. Here's another question for GRU. Have you found differences between field switching position and GIS model? How do you handle it when restoring services or transferring load during an outage response? Richard, I think I'm going to keep
I'll let Tony speak to that one.
Right.
It's more of his forte.
All right.
Hey, sorry. So they're looking for, have you found differences between field switching position and GIS model? How did you handle it, and then when restoring services and transferring load? So, I mean, the first part is it's all about safety, regardless what that is. So, I mean, if there's differences between the field switching and the GIS model, we're actually referring to other measures, right? So we talked about in our earlier about our one lines. So we keep those one lines up and make sure that, you know, if there's any switching taking place, that we're marking those one lines, and so we can refer to them at any time. And so we have several different sources to look at, right? You want at least two sources to view to make sure you're have the right information at hand to do the switching.
Right. There's so many good questions, and thank you to the audience for being so engaged. This is terrific. Don't think that I'm prioritizing. I'm just kind of taking questions as I see them, and there's so many good ones. So thank you for being so engaged. here's a good question. What are the main benefits of using OMS for coordinating and planning switching orders? Richard, you want to tackle that, or Sally?
For us, and Sally can speak to y'all's product, we have the switch order maintenance that we use for small switching, like burnouts and stuff like that, and the model those. And we're waiting on the upgrade that we have coming up to really let that shine as our own product. But we have a different switching order maintenance that we're using for the big stuff. But I'll let Sally speak to your products.
Sure. We have what we call a switch order management product that is specifically designed to help coordinate and manage switching for either transmission or distribution operations, and that can be fully integrated into OMS operations or DMS or transmission. So certainly you need to be coordinated, and that's important information that call center and operators need to have full visibility of what's going on in the system at any given time. So we have our own system, or you can interface to a third party system. I know there's other applications out there that do similar things, and pull that data back in.
Great. Richard, here's another question for you. Do you integrate with AMI, and what do you do when storms approaching? Do you turn them off?
What was that question one more time? Sorry.
Do you integrate with AMI, and what do you do when a storm is approaching? Do you turn them off?
So if AMI was on the other side of the fence, we're right on top of the fence right now. So we're in the project of integrating the AMI as we speak. We even have a meeting today to go over some of the security points about it. So yes, we are soon to be ADFS with AMI. Not quite there yet, and I don't know if we have a strategy in place for what's going to happen with our AMI system when a storm happens. We know what happened last year when we didn't have it integrated, what the AMI people did to help us keep our OMS updated. That was a manual process, and I'm not sure what we have in store or if we've really planned out what's exactly going to happen. Tony can mention to us, because I know he's been through some of those meetings already.
Yeah, we do plan on keeping the system up and running. This last storm we found with the AMI system out there, even though we're not integrated, we were able to use that and have our AMI team view some of those meters out there to confirm that there were in fact outages. We also found, and this is for any other utility, is that you need battery backup, because when the power fails out there, that we did lose some of the communication from those. And so once we got the circuits back up and running, we found that the AMI's back up and we're there. So lesson learned, we got batteries in our system to help us next storm.
Yep.
What I might add to that is just that, the more data into a real-time operational system, more real-time data like AMI data, makes the system more powerful. So now, instead of the GRU folks having to go to 2 different systems, they'll be able to go to one system and have all the meter data, all the live, be able to ping meters to check on things. There's live wire down features for AMI integration. So there's a lot of really interesting use cases that are enabled when AMI gets fully integrated into an OMS system. So it's an exciting next chapter for GRU.
That's right. Well, we are at the top of the hour, so that is all the time that we have today.
And Chris, if I can interject, if you have any of those extra questions that come in that are targeted to us, you filter them out and send them to me. I'm willing to answer anything that comes in.
Oh, that's great. Well, thanks, Richard. And we do have, this is a very engaged audience, and really great. And thanks so much for submitting questions, and we will send the appropriate ones to Richard. So I want to thank all of our speakers, Tony, Richard, Sally, Derek, and Ron, for all their insights. And obviously, I want to thank you, the audience, for joining us today and for really being engaged with the webinar. So thanks so much and have a great day. I'm going to hand it over to PJ to close us out.
Thanks, Chris. Fantastic conversation, everyone. Appreciate your time. Before we conclude, I do want to take a moment to thank AspenTech for making today's event possible. For our audience, please look for an email from us containing a link to the replay, probably early next week. And do take a minute to complete our survey as you log off to give us your feedback. We want to continue to provide you with valuable sessions just like today. From everyone here at Energy Central, thank you for joining us. We look forward to seeing you on an upcoming power session. Thank you for attending. This does conclude today's presentation.